Good morning, everybody. I hope all of you guys had a great weekend. I know I got a lot done. No work done, but I got stuff done. Yes, it was, Ronald. I'm not gonna lie, I'm a little over the 10-degree weather. We could go back to the 30s. Although my family in Wisconsin was in like the negatives, so I'll take Buffalo weather over Wisconsin right now. Zanzib, I had some paused audio in a couple videos in week 1, so I'm trying to make sure that doesn't happen again. So I'm messing around with the music, trying to find some good stuff. Morning, Tidy. So, okay, so having trouble with homework 2 with respect to what? Yes, JC Cubes. So your homework 1 is currently being graded. I have it hidden from you. Although you can't hide everything because apparently UB Learns also just gives you the total even if it's hidden. So what you see there, if you have a grade, a total grade, it is part of your homework 1 grade. It's not all of it. So there's 2 problems for homework 1. One of the problems is being graded by one person. The other problem is being graded by another person. So they're going to put the grades in separately. Every grade will be done by Tuesday evening. So Wednesday morning, you will have your full homework 1 grade. If you see a current grade, ignore it. It is not complete. It is not your final grade or total grade. It's just part of your grade. I did not get around to grading things this weekend. I really need to do that probably tomorrow. Port your grades over from Zybooks and grade stuff. Morning, Joey. So Trigger Happy Eli and Flora. This was a question on the quiz. A lot of students, or not a lot, several students had questions about how to run a function, how to check it in MATLAB Grader. So MATLAB Grader, Ronald, so it's all of your code is looked at by a person, and it is manually, it's manually checked. I should say. It's run, your code is run to make sure it runs. It's looked at by a physical person, and your variables are checked for the right answers just like they are in MATLAB Grader. Okay, homework 3. I'm not going to get to homework 3 right now. Homework 2. Did I assign my variables to homework 2 and I wrote the equation, but my value for current gives me an error. It depends on the type of error. You can, it depends on the type of error. Go to office hours, email me, put on the Discord. What error do you get? It depends on the error. Maybe you forgot a multiplication sign. Maybe you forgot a parenthesis. But if it's your equation, then just double check it. You may have forgotten how to translate from math terminology into programming terminology. Okay, so lecture is beginning. Before we begin, I just want to make a few comments. Several people, so when you guys fill out those comprehension quizzes, let me just give you a strategy tip. First things first, try it once, maybe twice. If you don't get a full grade, then pause and wait until maybe Tuesday to try it again. Come to lecture, see if it helps clarify things, and try it again. A lot of you guys mentioned that you're having troubles finding arrays. Those videos are not meant to be comprehensive. They're not meant to show you everything. If you notice, I didn't really pull up MATLAB very much in those videos. I was kind of like, here's some stuff you can do, but I didn't really go through step by step how to create things. We are going to do that in lecture. Those videos are just meant to introduce you to the concepts, introduce you to the ideas. So some of you guys were like, this is my third try and I can't get it right. Like, what is going on? You were frustrated. Please don't take that out on me. Just a tip. Try it again, maybe later in the week after you've had some more time to practice, after you've had some more exposure to the material. Okay, that's tip number one. Tip number two, a lot of you guys mentioned you're having difficulty with arrays. I assume you're having difficulty with arrays. You've never done it before. So when I'm asking you what you're having troubles with, I'm mostly asking you, what are some things you might need to clarify from like the homework? Like someone already mentioned today, how do you run a function in the editor? Questions like that, something that I can quickly review. It gives me an indication about how you guys are doing on the previous material. Okay, so here we go. So like I said, someone had a question on how to run a function in the editor. So if you remember from last week, Wednesday, also note, I changed the header. Woohoo! Remembered that this week. But if you guys remember from from last week's function video, also, if you need to, go back and rewatch the video. Rewatch it at like 1.5 speed or something, or 2.5 or 2 times speed. And you can maybe catch some things that you didn't catch previously. Okay, so let's say we have a function in our editor. You cannot press run. It will give you this error that says not enough input arguments, because it doesn't know what you want to use for R1, R2, and H. You need to call your function from the command window or from another script file. So to call a function, remember, it looks essentially just like this. Copy, paste that wonderful thing in, and change these values. What do you want for a value for R1? 2.5. What about R2? 3. What about H? I don't know, 4. And then you can press enter. There we go, I called my function. So now it used 2.5 for a value of R1, 3 for a value of R2, 4 for a value of H. Did these calculations. Whatever it calculated for SA, it's stored in this variable. Whatever it calculated for V, it's stored in this variable. And I can rename those. I can say SA1, V1. There we go. Okay, so remember, you cannot run a function file. It gives you not enough input arguments. So what you'd see in MATLAB Grader, you're checking just your function. There's that second box at the bottom. That's the code that you're using to execute to run your file, to test it. Okay, let's go ahead and jump into today's material. So, will that in the command window show up when we submit our work? No, you do not. You just submit the function file. You just submit the file. I will run your function, we will, the graders and the TAs, will execute your function using the command window or using another script file. So you just submit your function file. Okay, so there were a lot in the notes. Well, actually, when it comes to material, there actually wasn't that much in the notes comparatively to other weeks. But in the notes, there were a lot of just information on how to create arrays. So week 3 is where things start to differ quite a bit between MATLAB and other languages. So you guys saw that MATLAB uses something called arrays as an inherent data type. A lot of times when you're learning other languages, you don't get to arrays until significantly later. But MATLAB thrives on arrays. Every single variable, you didn't know this, but every single variable is an array. So we've been working a lot with scalars. Single values. It's a 1-by-1 array, 1 row, 1 column. So everything we've done, technically you've been using arrays, but they're just scalar arrays. And then I talked about row vectors and column vectors and matrices, and we talked a little bit about how to create arrays. So keep in mind that brackets are used to create an array. Some of you guys were using brackets in your expressions for homework 1, and that technically was not incorrect. You were creating a 1-by-1 array, a 1-by-1 array. But we use brackets explicitly for creating arrays, and then parentheses are used to group. And MATLAB will tell you that with warnings. They'll give you those little squiggly lines. I keep seeing those recently. It's like, if you want to group things, use parentheses. Even when I'm using brackets. But it's not technically incorrect, but just keep in mind brackets for arrays, parentheses, grouping things. Okay. So we learned how to create arrays. We will go through lots and lots of examples. And then a key piece is indexing arrays and then modifying arrays. So we will go through all of that fun stuff. But as we go through this material, I want you guys, where is it? I want you guys to remember this concept, where we already know that we have the equal sign. On the left-hand side of our equal sign is our variable. Think about where do we want to store these values. And on the right-hand side is our expression. Think about what do we want to store in our variable. So this is the main key. This should be in the back of your brain as we go through a lot of these examples. So today, I just pulled up a whole bunch of, I pulled up a previous homework, and I'm just going to go through creating a whole bunch of stuff. Because this week is all about creating arrays. Next week, we will get into the more complicated details about using arrays in mathematical expressions, with mathematical operations. But this week, it's really just all about creating and modifying arrays. So let's go ahead and start. So I've got this janky setup. I was just like, I want to see both at the same time. So up at the top here is my notes, and we can see one prompt more or less at a time. And down here is MATLAB. So my overlay doesn't quite match up because I created this overlay myself. If you can't tell, it's beautiful. But we're gonna do both of these things. And I have MATLAB set up like this. I'm gonna close out my current window or my current folder so we can see what I'm typing in the editor, what shows up in the command window, because I'm gonna leave my semicolon off quite a bit, and then what it looks like in the workspace. So first things first, it says create a row vector with the following elements. Okay, so I'm going to start writing up here a row vector. And that means it's going to be a 1 row by however many columns. And there's 1, 2, 3, 4, 5, 6. So it's going to be a 1-by-6 row vector. I'm going to create it by using brackets. So open, close brackets. And then I'm literally just going to type each of these pieces in there. Each individual expression is going to be an individual element. So I should have 6 different locations where I'm going to type. I can separate them by spaces, which technically is less typing, or I can separate them by commas, which is a little bit clearer, but you can do either. You'll probably see me do a combination of both. Okay, so let's go ahead and start typing. Note, I don't have a left-hand side to a lot of these. I don't tell myself what to name these variables, so I'm just gonna call them whatever I want. I'll start with R1. So in MATLAB, it looks like this. R1 equals, open close brackets, because I am creating a new array. And then I just type each element. 1, that's my first one. Then negative 2.1 cubed. Then 17 divided by 6. Then 1.125 times 7.5. Note, I can't do x, I can't do parentheses, it needs to be multiplication sign or the asterisk. 8 e to the negative 4 and cosine of pi over 4. I believe that's all of them. So keep in mind, every element can be an individual expression. I don't need, so if I did spaces in between here, it's going to take this as an entire piece. It's not going to say that it's 1.125 and then, oh, there's a space. It thinks it's a new element. It's going to complete the expression. So that's why commas can be a little bit clearer to indicate that, yes, there is a clear distinction between elements. So let me go ahead and execute this line of code. Note when I run it, R1 is a 1 by 6, just like we mentioned. Hold on. There we go, it's a little bigger. So it's a 1 by 6, just like we mentioned. In my workspace, it does show me all the values because there's not that many. It shows me the min, max. If you want more, you just right click and choose whatever ones you want. And we can see in the command window, I left my semicolon off in my editor. So in the command window, it just literally prints it out like it's a row. Okay, so that's my first one. Row vector, I can type in my elements all together. So let's get to the second one. So it says create a column vector now with the following elements. Okay, so once again, I've got 1, 2, 3, 4, nope. 1, 2, 3, 4, 5, 6. So this is going to be a 6 by 1 because it's a column vector. I'm still going to use my brackets and I'm going to type in each of my elements. Now, instead of separating them by spaces though, I have to separate them by semicolons. So keep this in mind. Semicolons are used to suppress output at the end of every line of code. I'll comment that or semicolon that now. In creating arrays, semicolons are used to stack things on top of each other. So that's the two contexts, two locations, two places where we use semicolons. At the end of each line of code, and then to stack things on top of each other in creating arrays. Commas, if you noticed, were used to put things next to each other. That comes important when we get to concatenation. And then I'll name it whatever I want, C1. Okay, so I go back over to MATLAB. C1 equals open close brackets because I'm creating a new array. So mprow, that is really just depends on what you're doing, and you'll see that when we get to mathematical operations. It really just depends. Sometimes I like things to be in semicolons, in columns. Sometimes I like it to be in arrays. It really just depends on how you want your data organized. That is a good question. And I'm just typing everything in. Coast D40, 38.7, and nth root 89.4, and then sine of pi over 6 divided by tan 25. Okay, it went off the page, but that's okay. So now when I run it, R1 is suppressed, so it's going to be printed out, and it's going to execute both, and we can see that C1. If you notice, I didn't put semicolons in between things. I put commas in between them. So C1 actually turns out to be a row, and you can see that here in size. If I want to fix that, I just put my semicolons in. Semicolons everywhere. That is one way to fix things. So now C1 shows up as a column. So Matt, this is where one of those instances where if you had a really long array with more than 6 numbers, as a row, it would keep going and it would keep going off the command window. We'll see how it wraps around in the future. Whereas in a column, it's just nicely stacked. So it depends on how you want to see your data, how you want to work with it. Okay, so that's one way I can make sure that they're columns. Another way I can make sure that it turns into a column array is by using the transpose. So if you remember, there's a couple ways to do transpose. So here I took my semicolons out and back to C1 being a row. If I want to make that a column, I can put in my semicolons, or I can do transpose. So transpose is just an apostrophe. Transpose is going to make the rows into columns. So if I add this apostrophe here outside of my brackets, it's going to take this row and make it a column. So this is the second way that I can make a column vector. I can type a row vector and then transpose it. Okay. And we'll see more examples of that. Okay, let's keep going. So we've typed things in. This next one says create a row vector with 6 equally spaced elements. Equally spaced, that's our key word. Equally spaced elements in which the first element is 60 and the last element is 15. And there's a couple ways I can do this. Equally spaced means I can use the colon operator, or I can use linspace. Note this text here gives me the number of elements. Number of elements is 6. The first one is 60 and the last one is 15. If you are given the number of elements, the first number and the last number, it makes sense to use the linspace function. So linspace. So linspace is a function. So we type the name of the function followed by open close parentheses. And the linspace function gives has 3 inputs. We need to send it 3 pieces of information. The first value, the last value, and then the number of elements. And then I can store that in another R2, another variable. So I go back to my text, go away, and say R2 equals linspace, open close parentheses. I send it the first number, which should be 60. That's what it tells me. The last element should be 15. And then the number of elements is 6. So now when I execute this line of code, R2 is going to be a row vector where the first element is 60, the last element is 15, and linspace did all of the nice calculations in between. It decided that they're equally spaced, so the spacing between 60 and 51 is 9, between 51 and 42 is 9, between 42 and 33 is 9, between 33 and 24 is 9, and between 24 and 15 is 9. Linspace will always decide, they will always have the first value as 60 and will always have the last value as 15. Another way I could have done this, I could have said R2 equals 60 colon 15. And then I could have figured out the spacing myself, which in this instance would be -9. So both of these will give me the same vector. Linspace is easier because I don't need to calculate what my spacing is going to be because I'm told 6 numbers. But I can also use the colon. Okay. This used to be my preference. Now this is starting to be my preference. It really just depends on the information I'm given. If I'm given the number of values, I tend to use linspace. If I'm given the spacing, I tend to use the colon, even though I know I can calculate the spacing anyway. Okay, so there's R2. Let's keep going. Okay, then it says create a column vector, 6 elements that are all 23. Okay, so that's pretty simple. I could just type them all in. So they're all 23, so it's all the same number. I have a couple options. I could just type them in like this, where C2 equals 23, 23, 23, 23, 23, 23. And that's fine. That's not a big of a deal. There is a shortcut though. I could also use the linspace function again. So remember, linspace, I need the first number, the last number, and the spacing, or the number of elements. So if I give it the same first number and the same last number, it will do a spacing of 0 and just repeat. So here's why I type them all in together. Remember, linspace gives you a row vector. So if I want to make this a column vector, I just put in my transpose again. So now it turns into a column. So a lot of these arrays, there's more than one way to do it. Some ways are more efficient than others. Some ways are more adaptable than others. Like if I use this option and I'm used to this option, then it doesn't matter how many elements I have. I could do 100 and it will give me a vector of 100 elements. Whereas if I had to type all those in, that would make it would take a lot more time. Okay, so some of these are a little more adaptable, a little more usable beyond just 6 numbers, beyond just 10 numbers. Anytime you get above 10, it's a little tedious. So try and come up with as many shortcuts as you can, unless you have to type them in because there's no real pattern. Try and come up with as many shortcuts as you can, even if it's for a small, vector. Okay. So here it says create a row vector of 6 elements that are 0, 0, 6, 0, 0, 6. Once again, I could type it in. I could just say, literally look like this. I'm going to show you guys a little bit better of practice for this. So one thing I noticed is that most of these elements are 0. So what I'm going to do is I'm going to use the zeros function to create an all zeros vector. So R3 equals zeros function. I'm using a function, so I write the name of the function followed by open close parentheses. And then for the zeros function, I'm going to give it 2 numbers, the number of rows and the number of columns I want. So for this one, I want 1 row, 6 columns. So if I do that, 1 row, 6 columns, it's going to give me all zeros. And we can see over here in my command window. Now I want to change this element and this element to 6. So I've got all of my zeros. And I want to change this one to a 6 and this one to a 6. So now we're starting to get into modifying arrays. And like I said, for the videos, it's to introduce things so that you're not completely blind when I go over examples and kind of skip over the material. This is one of those instances. Jada, that's actually a matrix. So here I have, so I want to change this one to a 6 and this one to a 6. Okay, so R3 is already created. And I want to change, so I start location 1, 2, 3, 4, 5, 6. All of my locations are 0. I want to change this 3rd number to a 6 and this 6th number to a 6. So once again, we're looking at that expression of where do I want to store things? What do I want to change it to? So here I want to store something in my R3 vector in specific locations. So if I want to do that, I'm going to type the name of my vector, followed by open close parentheses. What am I going to change it to? A 6. So I go back over to MATLAB. I want to change R3. I want to change specific locations of R3. So here's one of those things where on this side previously, it was all just single variable values. That means we want to change everything. We want to create R1. We want to delete any previous R1s and completely change it. Here, though, here's a difference where we're going to change part of R3. So R3, I want to change locations 3 and 6. So notice I put 3 and 6 in a vector because I'm doing more than one. I could do it separately. I want to change location 3 to a 6 and location 6 to a 6. So here's where I do it separately. So here's my first one with zeros. Here's where I change the 3, and here's where I change location 6. If I want to do that together, I would just do 3, comma 6. There we go. So that's one of the ways to create this kind of vector. Another thing we can do is literally just comment this out. Technically, we don't need this line 5. I strongly, strongly encourage you to have line 5. This is, in my experience, poor programming practice. So you should always, if you're not going to create a vector with all of the values, you should initialize it to zeros or ones. So Matt, that's a good question. You can't do a 3D array in one line of code. You have to do it in multiple lines of code. That would create just a 3 by 20 or a 20 by 3 array. You just added one more row or one more column. If you wanted a 3D array, it's beyond the scope of this class. We're not going to get to 3D arrays, but you would need more than one line of code. And if you want, I can show you at the end of class. Okay, so there's how we can create R3. So like I said, technically you don't need line 5. It will work. If I clear my workspace and just did this, it will automatically fill these uninitialized values with 0, but that's, in my opinion, poor programming practice. Okay, let's keep going. That one was a little more difficult. So now it says create a matrix where the previous vectors are row vectors. So I'm going to take row 1, row 2, column 2, row 3, and make them into a matrix. I'm going to call it M1. So I'm creating a new array, so open close parentheses, where my first row is row 1. My second row is going to be column 1 transposed, so it becomes a row. My third row is going to be R2, then C2 transposed, then R3. Remember, commas are used to put things next to each other. Commas and spaces put things next to each other. I want to stack these on top of each other. So I want row 1 to be on top of column 1, on top of row 2, on top of column 2. So typically when we create a matrix with rows, we just put semicolons in between. So now M is a 5 by 6, 5 rows, 6 columns, and we can see it printed out in my command window. Keep in mind, all of your rows need to be the same length. So if I had like 5 values here in row 2 and ran it, it would give me an error that says dimensions of arrays being concatenated are not consistent. Concatenation is where we are combining rows, columns, matrices, arrays, whatever, to create bigger arrays. So when we create a matrix, we are combining rows or columns or matrices or other matrices into a bigger matrix. So this is technically concatenation, even though it's the most traditional way to make a matrix. Okay, so dimensions of arrays being concatenated are not consistent. That typically means somewhere you don't have the same number of rows or the same number of columns. So I can go back to here, I can see, oh, that's where it is, rerun it, and we can see the changes. And each of these rows can be created however you want. We can also do the same thing with columns. So it's not going to look exactly the same, but let's say I wanted to create another matrix with all of these rows, all of these as columns. So I would say R1 transposed, next to C1, next to R2 transposed, next to C2, next to R3 transposed. So this will be the transpose of M2, or M1. So now I can see I put column next to column, next to column, next to column, next to column. So there's typically lots of ways to create matrices, to create vectors. It's really just, you'll get used to how things go. Just remember, commas or spaces are used to put things next to each other. I didn't have to put in commas. I could have just left it with spaces. Yeah, I could have just left it with spaces, because spaces and commas put things next to each other. Row or semicolons put things on top of each other. So it's your job to kind of visualize. If you can't spatially visualize things, think about it in terms of your size. Utilize your workspace. Look at your size. A 1 by 6 is 1 row. A 6x1 is one column. How do you stack things next to each other? How do you put things on top of each other? For starting out, I really like to use pen and paper. And you'll see why when we get to later examples. Okay, let's keep going. Are there any, I mean, you guys are asking questions as you go, which is great. Yes, okay, let's keep going. So here I say use the rand_i function to create a matrix. So now we're gonna get to modifying. We did a little bit of modifying here, but we're gonna get to more complex modifying. Keep in mind that it's this idea right here. Woohoo! Oh, that's not what I wanted. Come on. It's this idea here. Sorry about that. Where do I want to store things? What do I want to put there? And that is our big idea. For a lot of the previous ones, we were just creating new variables. Okay, so it says use the rand_i function to create a matrix. You guys don't need to know the rand_i function. I'm just using it as an example. You will get more used to creating or using functions you haven't used before. But rand_i creates a random matrix or random set of integers. Rand_i, random integers. It looks like this. You put in a maximum value or a range, so between -10 and 10. And then the size. I want a 5x7. So this is our random array. Note, it's going to be different random numbers every single time. So, but this is the A we're working with. Okay, it doesn't really matter what the numbers are. I don't care about the numbers explicitly. I just care how we're going to modify it. So there's A. Now I want to, the first thing that says delete column 3. Okay, so now I'm working with matrices. Matrices have rows and columns. So it says delete column 3. When we are working with matrices, we type the name of the matrix followed by open close parentheses. This is how we are going to modify a matrix. By identifying which rows we want to change and which columns we want to change. So when it says delete column 3, I want to delete all of column 3. That means if I look down in my matrix, I want all of these numbers to disappear. I want all these numbers to be allocated to empty. So the rows that I want is going to be row 1, 2, 3, 4, 5, or all of the rows. If you're talking about all of the rows, you can just use a single colon. So there's a lot of places where you might use a colon. There's a lot of places where you might use a semicolon and a comma. It just takes practice of knowing where you might want to do each of those. Sometimes it really helps to kind of talk your way through what you're trying to do, and then look up the syntax for that. So maybe write out a cheat sheet like, oh, a semicolon can be used to suppress the output. Semicolon can be used to stack things on top of each other. Regular colon can be used to, with that syntax in order to create a linearly spaced vector. Or a colon can be used to indicate all rows or all columns. So sometimes it helps to kind of talk yourself through what you're trying to do. So in this instance, I'm talking about all of the rows in column 3. So that is what I want to change. So if this is what I want to change, that means it goes on the left-hand side of my equal sign. The right-hand side of my equal sign is where I'm going to tell it what I want to change it to. So I'm changing all the rows, third column, and I'm changing it to delete. I'm changing it to empty, which is just empty brackets. What's the difference between creating an array as a row or as a column? So Joey, that a row is these dimensions. So really, you need to pay attention to your dimensions. Do you want to have 1 row, 6 columns, or do you want to have 6 columns, 1 row? Sometimes it's not going to matter. Sometimes it doesn't matter how you create it. Sometimes it's just your preference. However, if you are using it in to create a matrix, then it matters because you can stack rows on top of rows or columns next to columns, or put columns next to columns. So then it matters. So it really depends on what you're trying to do. If you are told to create a row vector, you want to create a row vector. If you're told to create a column vector, you want to create a column vector. So it really just depends on what your application is, what you're trying to do. Okay, so if I have this A matrix and I want to delete column 3, I would say I'm trying to modify part of A. So A, open close parentheses. I want to take all of the rows in column 3 and I want to delete them. Deleting them, you just set it equal to empty brackets. So when I run this, now A is a new set of numbers. Once again, it doesn't matter, but we can see that A originally had 5 rows, 7 columns, but I deleted this one. When you delete it, MATLAB just takes it out and shrinks it. And now I have 5 rows, 6 columns. Keep in mind, you can only delete 1 row or 1 column at a time. You can delete more than 1 column at a time. It really just, here, identify which columns you want. If you want to delete a row, you would just switch this. You want to do what rows in all the columns. Okay, so let's get to the second one. Oops. Access the element in row number 4 and column number 3. So once again, if I want to do something with the element in row 4, column 3, I'll just type the name of my array, open close parentheses, which rows, which columns. In this instance, it's a single number, the number that's in row 4, column 3. So now A looks like this, row 4 looks like this, column 3 looks like this. So the overlap of those is -7. So if I typed A, 4, 3, oops, that's not a 3, it would give me -3. Now, typically that would show up on the left-hand side or the right-hand side. If it was on the left-hand side, that means I'm going to change the number. If it's on the right-hand side, that means I'm going to use the number to do something. So when we grab numbers or subarrays inside of a matrix, it can show up on the left-hand side or the right-hand side. On the left-hand side, if you're trying to modify the value or values there, the right-hand side, if you're trying to use those numbers there in some sort of expression, which we will get to more next week. I'm just gonna leave it like that for now. Next one, create a subarray that consists of columns 1, 2, 5 of the matrix. So once again, if I want to do something with these numbers, inside my matrix, I type the name of my matrix, open close parentheses, list out the rows, list out the columns. In this instance, I'm talking about all of the columns of 1, 2, and 5. So all of the rows in columns 1, 2, and 5. So once again, all of my rows. And now my columns 1, 2, 5. I can just list out more columns. So over in MATLAB, I'm going to say A1, my first subarray, A, all rows, columns 1, 2, 5. So now A1 grabs columns 1, 2, and 5 and puts them together. So note, it effectively removes columns 3, 4, and 6, but it's just going to take them all and grab them together. I could change this as well to identify which rows. So maybe I only wanted rows 2, 4, and 5. So now it's even smaller. It grabbed the values in rows 2, 4, and 5, also in columns 1, 2, and 5. Okay, so let's keep going. Create a subarray that consists of rows 1, 3, and 5 of the matrix. So same thing, open close parentheses. I'm trying to grab values inside. Dang it, I keep pressing my erase button. I want to grab the values inside of this matrix A, which rows, which columns. I want rows 1, 3, 5. Which columns? I want all columns. So colon. So go back to MATLAB, call it A2. I want to grab the values inside of A, go away, in rows 1, 3, 5, all columns. So now it grabbed rows 1, 2, 5, or 1, 3, 5, all of my columns. Let me change this back. Okay, so now I have A1 and I have A2. A1, 6. A1 is a 5 by 3. A2 is a 3 by 5. And let's say I want to combine A1 and A2 into a single matrix called A3. If I want to create a new matrix, I click open close brackets, and let's say I want to put A1 next to A2. Notice I can't just say A1, A2. That will give me an error. It will say dimensions being concatenated are not consistent, because I can't just place these numbers next to A1. It needs to be square. But what I can do is I can transpose A2 so that it's flipped up on its side. A2 transpose is going to have 5 rows, 3 columns, because it's going to be flipped. That I can put next to A1 because A1 has 5 rows. So notice on this side was A1, and on this side is A2, where I transposed A2 so that I have the same number of rows as A3. I could also place them on top of each other. I could say A1 transpose, so that A1 transpose has 3 rows, 5 columns. So now it's A1 transpose on top of A2. So once again, it really just depends on how you want to put things together. Make sure that when you're making an overall, a bigger matrix, more than just a row or a column, you use semicolons to stack things on top of each other, commas and spaces to put things next to each other. And just keep in mind what your dimensions are. Like I said, I like to draw things out sometimes, and we'll get to that in 2 more examples. Sometimes for this one, it really helps to leave the semicolon off so you can actually see what's printed out in the command window. This only works for smaller arrays though. You might have to work with your workspace and see these dimensions here for bigger arrays, but for your homework 3 and for the next couple homeworks, you're going to be working with relatively small data sets. When we get to, I don't know, week 6, week 7, you might have bigger data sets. And then your project is going to be much bigger as well. And I'll show you how to look at that information without using the command window as well. MATLAB is really nice because you can always see your numbers. So if you run into a dimension mismatch situation, you can always print something out. If you want to, you can double click on the workspace variable. So if you ever want to open up and see your numbers, just double click. It will open up called your variables, and you can see your numbers like they are in Excel. That might be really useful for the future. So you just double click it and it will open it up. That's really useful if you have bigger values. But if you ever run into a dimension of arrays being concatenated or not consistent, just check to see, oh, what's the size of this one? What's the size of this one? Maybe draw out on paper why things aren't aligning. Okay. And then it says, okay, we already did that one. Determine the dimensions of the matrix. Dimensions of the matrix. That we can do with the size function. So for the size function, there's a couple ways to do it. We type size, open close parentheses, and we just type the name of the array that we want to figure out the size of. So if I want to determine the size of A, I just say size A. I can get the data in a couple different ways. I can get the data in a single 1x2, let's fix that, in a simple 1x2 array, where the first number is the number of rows, the second number is the number of columns. That's one way to use size. The other useful way to use size is RC, where I can get them into 2 different variables, where the number of rows, or R, is going to contain the number of rows, and C is going to contain the number of columns, because R is the first output and C is the second output. Keep in mind, it does not know what you name your variables, so you could say C to contain the number of rows and R to contain the number of columns. Okay. Oops. If I want to figure out just the number of rows, I can say size A1. That tells me how big the first dimension is. If I want to figure out the number of columns, I can do size A2. So there's lots of different ways to use the size function. Use whichever one is useful. Okay. I'll leave those there for notes. Let's get down. Yes, so size A1. So it says, so essentially what you're asking for is determine the size of the matrix A. Tell me only the first dimension, the size of the first dimension. So the dimensions are rows by columns by the third dimension, by the fourth dimension, by the fifth dimension. That's essentially how we read matrices. So the size, you can have any size dimension matrix you want. In MATLAB, you can only create 2Ds on a single line. If you want to do 3D, 4D, there's additional notation for that. But the size here, it says you want the size of the first dimension. So how many rows are there? Here's the second dimension. How many columns are there? You could technically do the number of pages, I guess, is the Z. 3D would be size of A, comma 3. 3. You could do the fifth dimension. Let's see what that gives us. Yeah, the fifth dimension is 1. Because it's just 1 by 1 by 1 by 1 by 1 by 1, or 5 by 3 by 1 by 1 by 1 by 1 by 1. This just tells you which dimension you want to grab. Number of rows, first dimension, number of columns, second dimension, third dimension, fourth dimension. How many dimensions are there? And how many elements there are in the dimension? Yes, absolutely. Yep, that's exactly how you can read it. Size, array, comma, dimension. Okay, let's get into a couple more examples. Let me get into this one. Let's do G. Let me zoom out a little bit. So let's say we want to create G, and this will probably be our last example. And then on Wednesday, we will continue to do more examples. So if you want to, by Wednesday, if you didn't figure out everything for the quiz, go back to the quiz. You can retype in some things that I should go over that I didn't cover today that I can focus on. I was planning on going over some of your Zybooks challenge activities as well. I mean, I'm just going through lots of examples. I'm throwing a lot of information at you today. It's not, I don't know, maybe we'll do a lot more modification. There's just a lot in this chapter. And you really don't know the implications of everything that we're doing today yet, because there's just so much in this chapter. And really, this is an area where MATLAB is really good at using arrays, creating arrays. But unfortunately, that means you can get into trouble a lot easier. You will run into dimension mismatch a lot. Okay, so let's say we want to create G. So here's a matrix called G, and we want it to look like this. Like I said, using paper can kind of help in situations like this, where you can break it down into individual components. So if I look at G looks like this. It has this big chunk of here, that's a bunch of 2s. It has this chunk of here, that's 1s, and this chunk of here, that is 0s. So each of those are essentially their own subarrays. So sub 1 would be a bunch of 2s. So essentially, I would say 2 times 1s, and it's 3 rows, 2 columns. And so we haven't necessarily learned this notation yet, but this is one way that we can create a matrix full of a bunch of single numbers. We can just say 2 times, and then whatever the 1 is. So here's S1. Nope, that's not what I want. 3 rows, 6 columns. There we go. So here's S1. Here's the top of my G matrix. Then S2, this bottom corner here. Come on, stop hitting. This bottom corner here is just full of a bunch of 1s, and it's 3, 3. So here's the bottom corner. And then S3, the other corner is this one. So also a bunch of single numbers, but here I would use the zeros functions, 3, 3. So now I've got my individual components. Now I want to combine them together. To make my overall G, I'm creating a new array where I'm going to place S1 on top of S2 next to S3. So it's S1 placed on top of, so I'm putting a semicolon, and then S2 S2 next to S3. Note, I put S2 and S3 in their own brackets because I want it to do this first. I want to create this array first. Brackets in creating arrays is kind of like parentheses, order of operations. It creates this array first and then puts it underneath here. So now I can see I've stacked G together, where I put this 2's on top of the 1's next to the 0's. And I can do this all in one array as well. Looks like this. Copy, whoops, paste, copy, paste, copy, paste. Same thing. So as you get more comfortable in things, you will be more comfortable in doing it all in one line, or if you want to do it in separate lines, that's completely fine. Okay, that's all we have time for today. I feel like I just kind of like threw a bunch of garbage at you. Hopefully things kind of made sense. Hopefully it clarified some things. We will do lots more examples on Wednesday. There's some more I have on this sheet of paper that I can go through, specifically with modifying arrays. And then if you look at your Zybooks for this week, there are a lot. So week 3, there's a lot of sections to go through, and that's because you're going through 2 chapters. It is the biggest section you will have to do. You do not have to do all of the challenge activities, only the ones that are assigned. So you'll have to do most of them in chapter 3 and only a couple in chapter 4. They can get pretty challenging. And like I said, we'll look at a couple on Wednesday as well. Okay, so that is all I have for today. Yes. Like I said, this is the biggest you will have to do. So if we get to week 4, week 5, week 6, week 7, week 8, you can see there's significantly smaller. Week 6 also is kind of big, but nowhere near week 3. Okay? So with that, I can stick around for a couple questions, but I do have to jump over to office hours. Any final questions? There's a lot. So just practice one thing at a time. Think about, where do you want to store something? What do you want to put there? I feel like this music is a little too pumped up for like the overload that we just had. Okay, I will see you guys on Wednesday.